Good morning. Good morning. Thank you for joining me. Today we'll be talking about dictionary. A dictionary is a collection of key value pairs. Okay. The one restriction with a dictionary is the key needs to be unique. Okay. So the key needs to be unique. And that's the one restriction on a dictionary. So let's get into how we create a dictionary. So here we'll create a dictionary using a generic initializer. So we'll say, we'll call our variable name generic or using generic initializer. And here we'll create an empty dictionary. So we'll say dictionary, angle square bracket, and the key, whatever key you want this dictionary to hold. And here, for example, I'll say the key is a string and the value are integers. And don't forget my initializer syntax here, open curly, open parens, close parens. So here we have an empty dictionary. We called it using generic initializer dictionary, just like that. And now we could populate it with key value pairs. So in my dictionary, let's actually populate it with or add a key value pair to it. So here we'll say using dictionary, just like that. And I want to add a key value pair. So for now, I will just say Alex, and I'll just put some number here to represent how many years I've been doing programming, for example, and I'll say 7, just like that. So this shows 7 years. And I will go ahead and print out my dictionary. So I'll say print using generic dictionary. I'll run my playgrounds. And here we'll see our dictionary now has a key, Alex, a value, 7, which is an integer. So this is how we create a generic dictionary using generic syntax. When I say generic syntax, I'm talking about the angle, the open angle bracket, and the close open bracket. If you want to look at generics, we'll talk about generics later in the course. But for now, this is what a generic syntax looks like using the angle brackets. So let's continue on. So I want to create a dictionary using subscript syntax, which is the preferred way to create a dictionary. So here I will say var subscript dictionary syntax, just like that. And again, it's going to be empty. And here, this time around, I will say my key will be an int, and my value will also be an int, for example, also using the open parens and close parens, right? Same as we did for our generic syntax. Same as we did before, I could populate my dictionary or add a value to it. So here I'll say subscript dictionary syntax, open square bracket, which is subscript syntax here. And for, well, very quickly, we have an error here because our key needs to be an integer, and I'm trying to put my key as a string. So that's not going to work. The compiler will complain here. So for my integer, let's just put in 2020, the year. And let's just put in the current month. Current month, we're in November, so we'll just put 11, just like that. And again, like we did before, I'll simply just print subscript dic syntax here, and I will run it. So here we see 2020, and the month is November 11, okay? So let's keep going on. If I was to say subscript, and go ahead and do 2020 and put in 11, for example, or not 11, 12. So here, this will update my 2020 to 12. So say December, okay? Let's print out again. Let's print out our subscript dictionary on line 20. And here we'll see we overrode November, and now we have December. Okay, good. Let's go on to talking about dictionary literals now. As we've talking about or spoken about literals before, literals is basically you create an object somewhat in place as opposed to creating an empty object first and then populating it. We will just create our dictionary. For example, if we were to create a dictionary here, call it languages, just call it cities for now. So we create a dictionary of cities, and here we will populate it. We'll say Sweden, and we'll say Stockholm, just like that. We'll say California, and we will say Los Angeles, just like that. And here we'll say, lastly, we'll just say Florida, and we'll say Miami. And let's go over this because a lot of things are happening here. We created a dictionary literal. Literally, we just created a dictionary using open square bracket, close square bracket syntax here, as opposed to creating an empty dictionary before and then populating it with values. So here we just give it the values upon creation. So we did not specify what type the dictionary is. The compiler now infers, if we use our option click here on cities, we'll see that the compiler inferred that our key is a string and our value is also a string. So we did not have to type annotate this. You could have type annotate it, but here it is not needed because the compiler will infer that this is a dictionary where the keys are strings and the values are also strings. Okay, and here this is a dictionary literal. Let's see what happens if we do something like this. So if we say Sweden and we say Malmö, for example, and we were to run this, print cities, right? So here we'll get an error, right? It says fatal error, dictionary literal contains duplicate keys. Okay, what does that mean? Well, earlier in our description of what a dictionary is, we said a dictionary is a collection of key value pairs. The key needs to be unique, right? Or is required, right? The key is required to be unique. We have a key here, it's Sweden. We have an X key here, so that's duplicates. We have two values, same key. That's a duplicate. We cannot allow that. We cannot have that. So the compiler now sees that and it throws this error saying, hey, you can't have a dictionary with the keys being the same. So we need to fix that, right? So we can't have Sweden twice as keys here, okay? And this is because the key itself in a dictionary is hashable. What does that mean? So the keys of a dictionary are required to be hashable, required to conform to the hashable protocol. Okay, so this hashable protocol here is part of the Swift language. Basically, it's a protocol that allows objects, in our case, our string conforms to hashable. So that means it's unique, right? I'm able to use a string as a key because this string conforms to hashable. That enforces that this particular string is unique. So I can come back and say using the next string that's similar to Sweden or is the same as Sweden, that will not be allowed. So that's the error we got because Sweden is a string. Strings conform to hashable. Hashable enforces uniqueness. So therefore, it throws an error when we try to do it in our dictionary. Good. Awesome. So this is where we are. We created this dictionary literal, and let's just run this again, make sure our cities do populate. So here we have our cities. Another thing I want to point out, you see how we put our cities here in order. We have Sweden, Stockholm. Why isn't it printed in order here? Well, a dictionary is not ordered. So in our explanation of what a dictionary is, we'll say a collection of unordered pairs. So a dictionary is a collection of unordered pairs of key value pairs, or key value elements. Okay, so a dictionary is a collection of unordered, it's not ordered as we see in our print statement here, right? Unordered pairs of key value pairs of elements, right? The key is unique. So there's a lot of restrictions or basically awareness that we have to be when we use a dictionary, right? We have to be aware of certain things. Like the key just can't be any random object that's not conforming to hashable. Let's actually take an example of what that looks like. So if I create an object here called, let's just call that object car, for example, and car has wheels, which is an integer. Car has color, which is, for now, we'll just say UI color. If we use UI color here, we'll have to use import UI kit because UI color is part of the UI kit framework. All right, so if we have a car and we want to say, okay, let's go create a dictionary, cars, like that, okay? And here we'll create, let's create an instance of a car. So Nissan is an instance of a car where hopefully it has 4 wheels and the color is black. We should probably have make here. Yeah, make, call it a string. So we'll have make where this is a string, call it Nissan, just like that, or brand rather. Okay, so we have a car, color is black as a UI color, black. And we'll create a next car. We'll create a Honda where car brand is Honda, has 4 wheels, and we have a red Honda. Okay, so now we want to go create a dictionary of cars where we'll create a literal. So we'll say Nissan, and we'll say, assuming we're a dealership or we're a car rental or whatever we are. So we'll say we have 10, and we'll say Honda, we have 15. Okay, so this is what a dictionary is, but here we're going to have an error. So the compiler says generic struct, right? Generic struct dictionary requires that car conform to hashable. As we said, the key, we're using the key Nissan here. This needs to conform to hashable, but our car is a custom object that we just created right now. This does not conform to hashable. So if you want your car to be a key, you need to conform to the hashable protocol, just like that. And now the compiler will be happy because our car conforms to hashable, which makes it unique. So here, if I use Nissan, I can't use Nissan again. Basically, that's what it means. So if I was to try to use Nissan again here, just like that, we'll get a very similar error like we had before, where it says dictionary literal contains duplicate keys. Okay, so we cannot use Nissan again, right? Because Nissan now conforms to hashable. We have a unique number, a unique key, so we can't use it multiple times. Great. Let's go on to inspecting a dictionary. What does that mean? If we have our dictionary here, for example, cars dict, I could say if cars dict dot is empty. If it is empty, then we have no more cars in the parking lot, for example. So we'll just put a print statement here. So if it's empty, print no more cars in the parking lot, right? And if not empty, we'll just say um, we are fully booked, just like that. So let's run it. So here we get we are fully booked because we are not empty. Okay, so hypothetically, just assume if we're not empty, we're fully booked. Okay, or there's actually, let's write a better one. There are still cars in the lot. Okay, that's probably better. Um, okay, so there are still cars in the lot because the dictionary here is not empty. But if it was empty, it would go to no more cars in the parking lot because it's empty. We could also count the amount of elements in our parking lot, for example. So we could say print there are cars in the parking lot. So here we'll use string interpolation. We'll pass in the name of our dictionary that we want to count, and we'll use the property dot count. So dot count is a property on any collection. It also works for arrays like we did last week. So here we'll say there are whatever amount of cars we have in the parking lot. So if I go ahead and run our playgrounds, here we'll see there are 2 cars in the parking lot. Okay. 2 cars, or 2 types of cars rather, because in our cars we have more cars, that kind of thing. Okay, so here let's actually update this. So there are 2 brands, it's probably better, of cars in the parking lot because each brand has multiple cars. So there are 2 brands of cars in the parking lot. Okay. Um, we'll come further down. Actually, let us, yeah, further down we'll use iteration, so we'll be able to see how can we see how many cars we have of each brand. So we'll actually probably use the cars example again here to get to the values. Okay. Accessing keys and values. This is probably where we are. So accessing keys and values. So here I could access, for example, this is probably a good use case to see how many cars in each brand we have. So here I will say let number of Nissans. Okay, this is good. So how can we find out how many number of Nissans we have? Well, I could use again our cars dict. Subscript is the way we access the key. So the name of my dictionary is cars dict. Subscript, whatever the key is, the key could be a string, an integer, or our custom type. So our key is Nissan, it's a car. So here I'll put in Nissan, okay? And this will return us a value. So there could be a value. So this returns an optional. If we option click on our number of Nissans here, we'll see that int optional. Our value is an integer. Why does this return an optional? Because maybe there's no key. Maybe there's no key for Nissan, for example. If I was to remove Nissan here, Nissan does not exist. Okay, so this returns nil. So instead of returning 0 or whatever, or -1, whatever it is, the Swift language returns an optional value. So if Nissan does not exist, it returns nil, meaning there's no value for this particular key that you're looking for. Okay, so this is why in our dictionary, whenever we want to retrieve a value from our dictionary, that value is always optional. So we have to unwrap the optional. So you could make a note here. Accessing values from a dictionary is always optional because the key may not exist. Okay, awesome. So here we have an optional integer. One way we could use nil coalescing to unwrap it. So let's do this. So we could use nil coalescing to unwrap it. So our 2 question marks like that, and we could give it a default value of 0. That's a good default value in our use case here, because if the key doesn't exist, that means there's 0 cars. So let's print out. So print number of Nissans. Let's just do there are number of Nissans in the parking lot. Okay, if I run this again, here we'll see there are 10 Nissans in the parking lot. We have 10 here. This is the value for our dictionary. Key, Nissan, value 10. Next key, Honda, value 15. Okay, how do you retrieve a value? You retrieve a value by using the dictionary, subscript. Inside of the subscript, you put the key. In our case, we're looking for Nissans. How many Nissans do we have? It returns an optional. One way to unwrap an optional is using nil coalescing here. So returns an optional. We will use nil coalescing to unwrap the optional. Okay. Other ways we could unwrap this optional, we could also use optional binding here. So I could say number of, let's use Hondas. So number of Hondas, we'll say cars dict. What are we looking for? Honda. So here we're using optional binding. Unwrap this value. It's an optional. If it does exist, put it inside of number of Hondas constant, and we have access to it at line 61. If there's no value for this particular key, it's nil. It will never get inside of our if statement. Instead, it will get inside of our else statement if we have one. And here we'll just say print there aren't just say there are 0 Hondas left. And here, if we do have Hondas, we'll just simply print there are Hondas in the lot. And here we have access to number of Hondas. Number of Hondas. So again, to go through this, earlier we used nil coalescing. We give it a default value of 0. That's how you unwrap an optional. Other ways to unwrap an optional, you could use optional binding here. Optional binding. And with our optional binding, we simply, if a value exists, it sets itself inside of the number of Hondas constant, and we have access to it inside of our body for the iflet block. If this is nil, it executes the else statement. So let's run our playground and see what we have. So it says there are 15 Hondas in the lot. If we take a look, there indeed are 15 Hondas in the lot. Okay. If we were to remove our Hondas, for example, and run our playgrounds again, we'll get a different print statement. There are 0 Hondas left because we have no Hondas in our dictionary. Let's put back our Hondas. Okay, awesome. Great. So let's keep going. We could access keys of a dictionary, again, keeping track or keeping up with our cars dict we have earlier. We could say keys, let's just say all cars. And we say cars dict dot keys. So dot keys, what's keys? Keys is a collection containing just the keys of the dictionary, right? So now if I option click on all cars, I'll get just the keys for the cars, or just the keys in the dictionary. In that case, all cars will just be cars. So if I print all cars like that, this is only going to give us our Nissan and our Honda, which are objects here. A better way to see those objects, we could probably just use a for loop here. So for car in, actually our cars is not able to print itself. So for now, let us, actually I just print out the brand, that's okay. So let's just do for car in all cars, print car brand is car.brand, just like that. And here we'll see car brand is Nissan, car brand is Honda, because we have 2 cars in here. So here we have 2 cars. So keys represents the cars. All cars is a cars array. Okay. So we reviewed arrays last week. So here we have an array of cars. You could use a for loop to iterate it. And through each iteration, here we have 2 cars. So we'll be able to get 2 brands of cars. The first brand is Nissan, second is Honda. Same thing for values. If I want to get the values of a dictionary, let us just use a new dictionary for now. Let us do, let grades equal to, we're using a string literal here. We will say, let's do grades. Grades is fine. We'll say Rachel got a 90. We'll say Alex got an 85. And we'll say Kim got a 95. Okay, cool. So how do we access values for grades? Basically, we just want to get the grades here. We'll say actually, let me rename this to grades. Like that, and say grades. We'll say grade dict dot values this time. So if you want to get to the keys, like the names of the students, you would say keys. But if you want to get to the grades of the students, then you would say values. Okay. And again, we have our values here. We could basically just print, let's just print grades. And here we have 85, 95, and 90, okay? 85, 95, and 90. Again, they're not ordered pairs, so this is not gonna be ordered. Okay, so let's go talk about first. What does first really do? So first returns the first element in the dictionary. Now, recall that the dictionary is not sorted. So whatever that first element is through that actual launch of the application is that first element. So we'll actually print what the dictionary looks like, and then we'll print the first element. So let's get a first element here. And the way you get a first element is we'll use our grades dictionary, and we'll say that first. Now that first here returns a tuple. As we see, that first returns a tuple of key value, right? In our case, the key is a string, Rachel, for example. The value is an int, 90, for example. So here we'll say first, let's just say first student then. Okay, first student, and we'll print our grades dictionary, and we'll also print first student. So let's go ahead and run. So here we'll see Tom is first. So Tom gets printed first, and Tom has a grade of 2. If we were to run the app again, this time around we have Kim in our dictionary appears first, and Kim returns first. Okay, so this is what first does. Random element gets us a random student, for example. So let's get a random student from our grades dictionary, and let us go ahead and print random student and run again. So here we have our dictionary where the first is Alex, and it got us a random element. Did we get a random student? Let's see. No, we did not get a random student. Let's do random element. So on my dictionary, I say random element. It returns a random element, in that case, a student. And now if I print, I'll get a random student. Rachel is random. That's okay. We don't have that many students. But if we run it again, this time we should probably get somebody else, which we do. Kim is first, which is fine. But if I get a random element or random student here, it gives us Tom, okay? So if you want to get a random element from your dictionary, you have the random element function at your disposal. Okay, so added keys and values. If I want to add a new key value pair to my, say example, grades. So I'll say grades. Well, first of all, grades needs to be a var because we're updating it. It needs to be mutable. So we'll say grades, dictionary, update value for key. The value I want to change or update, actually you could change the value as well. If the value exists already, it's going to change it. So let's actually see what that looks like. So if I say value, so it looks like Alex and I get 85. It's not a string. Alex got 89, for example. All right, he went back to get some more credit. So here, Alex, and let's see. So update value does a few things. Update value returns an old value for us. So this function returns a value. If I option click on it, here it says update value returns an optional int because maybe there was an old, actually let's just say old grade. So if there was an old grade before, looks like I got the old grade here. I'll be able to print out the old grade and also update Alex as well. So a couple of things we'll do. We'll print old grade, and we'll also print our grades dictionary. All right, let's go ahead and run that. So the old grade was 85 because Alex just updated his score from 85 to 89. But now Alex has 89. Okay. On the other hand, if there was not a value yet, for example, let's just say grades, update value 4, and here, not a key again, somebody got 100. Okay. Here we'll say Xavier. And if I print, first of all, let's say old grade, or we have old grade already. let's just say Xavier's grade. So now we'll print if Xavier had a grade before, and we'll also print our grades dictionary. Run it again. So here we have Xavier did not have a grade before, but now Xavier appears in our dictionary with 100 because we just updated. So update value does two things. First, it checks if the key exists. If the key exists, update the value. If the key does not exist, add the value to the dictionary. And we could also use subscript instead of update value. We could use subscript here. Syntax, which we mostly use in Swift, unless you want to use update value to retrieve the old value. So here we'll say grades dict, and here let's get in a new person. Let's add in Esther. Esther got 79. And if I print my grades dict again here, this time around, I'll see Esther got entered into our dictionary. So dictionaries are very cool, right? Very, very useful. So removing keys and values. We could filter, we could remove all. As we saw in arrays, we could remove all values from an array, but now let's go to filter first. So what we want to do here, we have some grades to work with. So now we probably want to do a filter. So let's filter everybody who's, say, above 92. Okay, so filtered students, just say that. And here we'll say grades, dict, and we'll say filter. So filter, let's actually just write in the whole filter function. So type in filter, press enter, and here we have, what do we want to filter by? Actually, let us redo this. I don't think I want the whole thing. Let's just use our trailing closure syntax. Again, this is trailing closure syntax coming up in a future lesson on closures. Okay, so what do we want to filter by? We want to filter where the value, where the value is greater than, we said 92, right? We want to filter where the value is greater than 92. So what does that return? That returns us an array, sorry, not an array. We did arrays last week. That returns us a dictionary where the key is the same string and the value is the integer. So in that case, we'll just get all the students where the grade is 92, above 92, so greater than 92. Let's see how many students we have. Actually, we could print how many students we have. So we could say print filter.count. So filter is a dictionary. How many students do we have? 2 students. So we could also print filtered students. And here we have Kim and we have Xavier. Okay, so if we look at what's our dictionary here? If we look at our dictionary, people above 92, Tom is not above 92, he just missed it. But we could include Tom, right? We could say greater or equal to 92 to include Tom. So now we have 3 and Tom is also included. Okay, cool, great. So this is what filter looks like. We could also do remove value. So for Xavier, for example, I could move Xavier here if I wanted to. So let's go ahead and use our grades dictionary and say remove value for key. So value for key, in our case, our key is Xavier. So you want to make sure the key is the key you want to move. In our case, this is Xavier. We have Xavier here. It returns the value removed or removed value. So we'll print that. And we also want to print what our dictionary looks like at this point. So let's print. Did we print remove value? No, let's go ahead and print removed value. Okay. So it removed the value, or the value that was removed rather is Xavier. So Xavier now no longer exists. And if we print our dictionary, as we see, Xavier no longer exists because it removed Xavier. If there was a value, it returns a value. We saw it, it's 100. He has 100. And if there's not a value, it returns nil. Again, optional. Or we could empty our grades dictionary and start from scratch. So in that case, we'll just say remove all. And if I print my grades dictionary now, it's going to be empty. So this is an empty dictionary. Good. We could also compare dictionaries together. So here we could actually compare them. So let us create two dictionaries. So we'll say dictionary 1 is, I'll just map those 2 years, I guess. Let's see. No, that's okay. Let's say 2010. So 2010, we'll say February. And here we'll come and we'll say dictionary 2. Also 2010 and February. And here we could say if dict2 equal to, if dict1 equal to dict2, then we'll say print same dates. And if we run it, indeed we'll get same dates, okay? On the other hand, if we were to create 2 additional dictionaries, I'm just gonna grab this and put it here and say dictionary 3 and dictionary 4. And we'll say 1010, so October, and we'll say 20, and we'll say 10. So here we clearly see this is not equal. So we'll say if dict3 is not equal to dict4, then print, this is dict4 here, print not equal dates. And run it. And here we'll see not equal dates, right? Because this is clearly not equal to this guy. Okay, awesome. Next, we'll go through iterating dictionaries. So I think we had a good example earlier with our cars, or we could use our grades. Actually, our grades is empty. So let's copy our grades again and bring it down here to iterate stuff. For each, it's okay here. We don't have a compiler error, so grades existed before. I'll just remove the var. And now we could say for grade, actually. So with arrays, for example, let's just review arrays. So arrays, I could say numbers equal to some array of numbers, 1, 2, 3, 4, 5. And I could use a for loop to say for num in numbers, print num, just like that. Okay, and I could run it. And it prints 1 to 5. In our dictionary now, so our array, an element is just one value. In our dictionary, an element represents a tuple, key value pair. So you have 2 values here. So if we have to use our for loop to iterate our dictionary, we need to represent what that looks like. So here we'll say, in our for loop, we could use open parens, close parens. Normally you would see key value like this in grades dictionary. But as we always do, you could rename this to whatever you want, especially if you want it to be relevant to what you're working with. In our case, we want to iterate through our grades dictionary. So it would be nice to say the key is a student and the value is a grade. So for each student, get the grade in the dictionary. So here I will print use string interpolation, say student, student got a grade on the exam. Okay, and if I want to run this again, here it goes through each element in the dictionary. So first element, again, it's not sorted. So first element, second element, third element, and fourth element. And for each of those elements, we have two values: a student, Rachel, a grade, 90. So we represent it that way to get access to it easily when we want to, say, print out the values in our for loop. Okay, awesome. Next, we have enumerated. So as we saw with enumerated back in our arrays lesson, I could say for get access to, this time around, we'll just say we want to get access to student, which is okay here. And we'll say student, and we have grade, and we also have grades dictionary, and this time we want to get access to the index. Okay, so in that case, we also want to get access to the index. So here we have, let's just call this student and call this, or actually call this index, because this is what it is. Index here, and we have student here. So we just want to get access to the index. So here we'll just say print student, or we have access to the student. We'll say student is at index, whatever the index is. Again, the index will be changed every time. Let's run this. Make sure we have this. So there we go. So the student in this case, contrary to what we have here earlier, this was a tuple of key value pair. In that case here, since we're using enumerated in our parents now, what we have is index and key value pair. Right, so this is what this looks like. So index and the student is the actual key value pair, or we could call it student grade. So it's a bit easier to read. Okay, it has both the student and the grade, as opposed to here. And the reason for this being, since we use enumerated, now enumerated gives us access to the index. So now we have access to the index plus the element. And the element represents our key value pair, where the key is the student's name and the value is the grade. Okay, so that's why we're able to access student here as a tuple. But I could say student dot key if I want to get access to the name. And now I'll say there are, or Alex is at index 3. You see it always changes. Again, if I run it again, let's see where Alex ends up. So Alex ends up at index 0. Because every time the app runs, a new hash value gets calculated, so the index changes. So there's no order. Again, dictionaries are not ordered. Okay, awesome. So let's keep going on. So finding elements. How do we find an element in a dictionary? Well, if we go back to our grades, again, I'll just copy this here so it's easier for us to access. I want to find an element. I will say, let's just say grade. I don't think we use grade yet. And say grades dot contains some value. And this is a tuple. So I'll just say student and grade, for example. And this returns us some Boolean value. Let's just say student exist. Okay. Oh, we could make this. Yeah, that's fine. Student exist. So here I basically want to say, does this contain, and here I could just return student equal to, we're finding the skip exists, right? And I'll print, or we don't have to print. Let's just use a control flow statement. So we'll say if student exists, if it's true, just print. Who are we looking for? We're looking for Kim. So just say Kim has, or Kim's grade has been entered. Kim's grade has been entered. Let's go through this. So we do a contains, we get access to the tuple, the student and the grade. Here you could do any sort of logic you want. It returns, but it has to return a Boolean value. In that case, we're comparing, does the student, the current student, equal to Kim? If it does, it returns true. So in our case here, we'll be able to run our code. And now we see Kim's grade has been entered because Kim exists. But if we're looking for a different student that does not exist, it would not come into our if loop here, and it would print else, print student needs to redo the exam, or something like that. And if I simply change this to Kenneth, let's just change this to Gabe. Okay. All right, so here we are. We have Gabe. We were looking for Gabe. If Gabe doesn't exist, we'll come here and we'll say student needs to redo the exam and run it again. And here we'll see student needs to redo the exam because Gabe clearly doesn't exist in our dictionary, but Kim does. If we go back to Kim does. We run contains, we're searching for Kim, she does exist. And if we run it again, we'll see Kim's grade has been entered. Okay, so here we are. Let's go ahead and, so we went through first already earlier. Let's just go through first index at this point. So the first index here, I could say let index equal to, we have our grades up here. Let's just get our grades back and put our grades right here. So we see it, it's closer. So we'll say, let's get the first index of some grade in this case. So we'll say grades at dict here, we'll say first index. We'll use trailing closure syntax here. So we'll say we want to get the first index where, for example, dot, let's get the value equal to 95, for example. Okay, so this returns us an optional dictionary index. So we could use that optional index. We could say if let, we could actually unwrap it here. We could unwrap everything together, but for now we'll just say if let found index equal to index. So we're unwrapping the index. If an index does exist, we'll say grades dict at found index. We'll just print this particular value here, print like that. And before we do anything, we'll just go ahead and print our grades like we did before. We'll go ahead and run it. We'll see that, did we run it? We printed it here. Okay, there we go. So we printed our grades and we searched for the index where a value or the grade is equal to 95. Indeed, we did get it. So we went and we printed out the index or the value at that index, which is Kim. Excuse me. So this is it. So if you want to find the first index, again, this only works because I'm able to get the first index at the launch of my dictionary. The index will always be different. So I can store that index somewhere and say, hey, go find me that index, because that index gets calculated every time the dictionary itself gets changed, because the dictionary is not ordered. So I can't, like, for example, say index 0, because that index always changes, right? I can't subscript directly using this integer value. Okay, so let's keep going. We have min and max. So if you want to find the min value or the max value of some dictionary, for example, we'll do one of those for now. We'll just do max. So here I'll say let max equal to, we'll say our grades dot max. And dot max is a closure. So I'll just use closure syntax, make it easier for us here. And what are we after? Well, here we after, we want to compare two values. So as we said earlier, if you want to compare two values, you want to use $0, for example, and $1 here. So what do we want to do? We want to basically sort this and return me a max value. Let's do it based on the grade. So the grade is value, and here the grade is value. So if you want this to be in this particular order, I say more than here. And if I print, if I option click first on my max, I see it's an element, which makes sense. So here I just say max element, and I will print max element. And max element here is Alex here because it's ascending. If I wanted to be descending, for example, I could do this, and I will get whoever has the maximum grade. In that case, it's Kim. Kim has 95. So this would be a better representation of what the maximum element is. Or we could rename this to say highest grade student or whatever it is, highest score student. So this is it, right? Max, we could also do it for min. You could actually just reverse this like we did earlier and get the min value. In that case, we will return Alex, who has 85, which is the lowest score here. So based on the closure that you pass it, meaning the more than sign or less than sign, you could use max if you want, based on what you're looking for. It could be the string, it could be the grade, like what's the highest value that you're looking for. Okay, so let's keep going. Transforming dictionaries. So here we have map values, we have map. Let's first go through map values. Map values returns a dictionary, and the dictionary maps the values. So map values, not keys. I could map the values, in other words, transform the values. So let us create a new dictionary. We'll do, let's do int to, what should we do here? We're gonna keep this simple. Let's just do keys to values like this. 1 map to 3, 3 map to 4, like that. That's okay. So we have int. So what is the type of dictionary here? The keys are integers and the values are integers. Okay. We just want to show an illustration of what map values mean. So basically what we're going to do here, we want to map over all the values of this dictionary and return a new collection. So I'll actually just make this a constant and we'll have a new value. So we'll just call this map numbers or values squared. Values squared. So what we're going to do is square each of the values, not the keys, just the values. It's called map values because it maps over each value. So what we're going to do is numbers dict dot map values and use the same closure syntax. The reason why we do this, because if you see here, it takes a closure. Again, we'll explain what closures look like as we keep going. So map values here, what I want to do is say for each value, just go ahead and multiply it by itself. Okay. And now if I go ahead and print my value squared, if I option click on value squared here, I'll see it's a dictionary. If I run it, indeed, actually we mapped our whole value, sorry. Let's not map the entire value. Actually we did, we good. So here we are. So 3 is mapped to 16. So if we see 3 here, 4 times 4 is 16. 2 is our key. 3 times 3 is 9. 1 is our key here. 2 times 2 is 4. So again, the keys stay intact and the values themselves are transformed. Okay, map is very similar, but in our case here, this particular map will simply return an array of any type. So it goes from a dictionary to an array of any type. Let's see what that looks like. And we'll actually conclude on the last, we'll conclude here with map. The rest is basically compact map values, sorted and shuffled, but we'll conclude on map here because this video was getting a bit lengthy. Let us conclude on map. So if we take an object, let's create some sort of object here. Let's create an object called person. Person has a name, which is a string. Person has an age, which is an int. So far, so good. So now we want to create some sort of dictionary here. Let's say we have a dictionary of person dict like this. And person dict holds, person dict is a dictionary. And here we have name, Rachel. We have age, 34. We have Henry. We have age, 29. We have Gabriel. We have age 45. And we have Tracy. We have age 41. Just like that. Okay. Our question is basically to take this dictionary and create person objects from this dictionary. So at the end of the day, we want to have a dictionary of person objects. How do we do that? Well, we have map. So map takes a dictionary. So each element of the dictionary is a key value pair, returns an element, a transformed element, and at the end, we'll have a transformed array of whatever type. It could be any type. There's no restrictions on the type we return. So here, let's create a people array. And the people array will say person dict. We'll use map, trading closure syntax. And here, what do we want to do? So each element, each of those elements we want to create a person object. So we simply have to pass in our person initializer here. So we'll say person name. Where do we get the name from? Well, this is the argument for name. So name is our key. And age we get from the value. Let's review this. So name is a tuple, or rather the first argument in our tuple. So it's key. So we have key value pairs. Rachel is a name, the key, and the value is 34, which is value here, which is an integer. So $0, our map function takes one argument. One argument, we denote it as $0. So there we go. So we are able to create an array if we option click on people. If we option click on people here, we'll see people is an array of person objects. So we went from a dictionary to an array of people. And again, this could be any sort of array, an array of booleans, ints, strings, our custom object person. And now if I go ahead and say, let's just do people, our people array dot for each. For each is also a higher order function. So here we just say for each, and we could simply say we want to print. What do we want to print here? We want to print the name, and we want to print the age. So name, we'll probably use string interpolation for this. Let's use string interpolation for this to make it easier. So print string, we'll say string interpolate name is age. And if I go ahead and I run this, there I have it. I have Rachel is 34, Gabriel is 45, Henry is 29. Okay, so this is awesome. This is a nice little tool to use. Again, map is very powerful, used a lot. Here we had map values. We were able to change the values of or transform the values in the dictionary. And we said we were going to stop here, but we could basically sort. Shuffle is what shuffle is. So shuffle just shuffles the dictionary. Sorted is interesting. So we've sorted, let's see what it returns. So if I want to, example, say sort person dict dot sorted, let's actually not do the full function. Let's use trailing closure syntax. So how do I want to sort this? I want to sort this with $0, $1. And I want to sort it such that our $0 value, let's sort it by value. And also here by value. And let's print what our sorted looks like. Actually, let's just call this sorted people. So print sorted people. And here we have Gabriel is 45, 41, 34, 29. So we see that it's sorted descending, right? Because we have our greater than sign here, but we could also sort it ascending here. Let's run this. So we have Henry is 29, then 34, then 41, then 45, okay? So it returns us an array of tuples. If we were to option click on our sorted people, we have an array of tuples or an array of dictionary objects. So we could very easily go through this for loop, say for person in sorted people and print person. Let's actually make this easier to read. So we'll say name, age. Okay. And here we'll say person or name is age old. And if we run this, we'll see, again, it's sorted ascending here. And if you flip this, and you run it again with the modern sign, it's going to be sorted descending. Okay? So this is again, this is one way you could sort a dictionary by having it return some sort of sorted array, and then you could use this array to do anything that you wish. Shuffled, as the name says, it just returns an array of shuffled dictionaries. But that's, yeah, because the dictionary is not sorted, so using shuffled, it depends on the use case you want to use it as, because the dictionary already is not sorted. So you could shuffle it at any point. Just do shuffled elements, just like that. And here we could say, what's our dictionary? Person dict dot shuffled, just like that. Okay. And that just shuffles the elements. So let's do print. Let's print our person dict first, and then we'll print our shuffled elements. So let's see what we have here. So our person dict is Tracy, Rachel, and so on. Our shuffled is an array of tuples, right? So it returns an array of tuples, not just like a dictionary object. So it returns you an array of tuples. So again, very similar to sorted people. Now you could iterate through this tuples array and do what you want here. Okay. So this was a bit much we did today, but it's good. If you want to see more, feel free to take a look at the Apple documentation here or the Swift language guide. Okay, so those are the two resources that every iOS developer should be familiar with as far as looking at the dictionary API further. Okay, again, thank you for watching, and feel free to like this video or subscribe to this video. See you next time.